Good afternoon everyone. Thank you very much for joining us today for this webinar. It's very nice to have you along. I realise these things can be a little bit strange. You're all sitting there with headphones on, maybe sitting in a spare bedroom, or maybe you're in the boardroom, or maybe you're presenting it to a lot of people. Believe me, it's stranger for me sitting here on my own talking to myself. But anyway, I hope you can understand me. I hope this is coming through loud and clear. And again, thank you very much for joining us. The point of today's presentation is to introduce IRT Surveys to you and to show you the very latest version of our software, Envision, and mainly to let you see exactly how it works and the benefits that you can gain by using such a system. The whole point of the software, since we've been developing this since about 2008, working quite closely with about 83 housing associations and an awful lot of local authorities, and listening to what they said about what they physically need and want from the software and what their tenants need. And subsequently they have been using the surveys on the doorstep and getting feedback from tenants. So this latest incarnation hopefully is the best of the best. The idea behind it is to help you benchmark your stock, roadmap a journey to the future, and to help people out of fuel poverty and to help increase and maintain the asset value of your current property portfolios. So without further ado, I will pass over to my brother, our technical director, Alan Little, and Alan will give you a bit of an in-depth look into exactly how to use the software far better than I can. So thank you very much. Alan, it's over to you.
Hi, this is Alan Little here from IRT Surveys, and today I'm just going to take you through a quick look at stock survey data and the types of things you can do with that data. So we're going to have a quick look at IRT surveys themselves, the process that we go through, how we do the calculations, what the data output looks like, and then some sample analysis basically on that data. So IRT Surveys have been going since January 2002. We're building an energy specialists. We now have multiple offices throughout the UK. We carry out infrared thermography, commercial and residential surveys, and we have online tools for carrying out interactive energy calculations. So to give you an idea of a typical project, so here we carried out thermal imaging of about 10,000 properties. The scope of the project was to quantify the regions of heat loss so that the client could see the best and worst properties, which ones were performing well. So under some of the EPCs and things they would have done, there would have been a tick box process where they would have calculated the energy efficiency of the property based on when it was insulated. So they would have just ticked a box to say yes, it was cavity insulated, and that's all they would have done. The other thing we'd do is look at the potential savings from different refurbishment measures. So in this project the survey was carried out between mid-November and the very start of March. When we do the surveys we always ensure we comply with the correct data capture conditions. So we always try to get a temperature differential of 10 degrees centigrade between inside and out. Dry conditions, so that it can't be wet or have rained in the last previous 18 hours. Wind speed less than 10 meters per second. And we always carry out all the surveys during the hours of darkness so that there's no solar gain on the properties. All the cameras we use are FLIR thermal cameras, and they have a minimum resolution of 320 by 240. So data supplied by client would be the following kind of information. So the minimum data we require are things like the UPRN, the age, the address, the postcode, the property type and its detachment, and also the wall construction. Ideally we would have things like the wall construction, loft insulation, windows, boiler, draft proofing, and percentage of low energy lighting. So typically this is a kind of spreadsheet we'd receive from a client. So you can see top row we have some data, and where we have question marks, that's where the client either doesn't know or they're not sure or they just don't have that data available. So you'll see that some of the data we've got lots of information, some of it we don't. You'll see bits where, let's say under the boiler, some of them we might just be told it's a combi boiler, other times we'll be given an actual make and model. So what we do with that data, the software initially, it looks at the basic information that it's given. So within the software we have maybe about 100 different templates already programmed in. So it's a typical, you know, Victorian house. Say it was like 1880. The rooms would be larger, the room heights would be bigger. You would have a chimney there, so drafts would be increased. So we have all these templates already built for a typical property of different age and construction. So what the software does, it looks through the spreadsheet, it finds one that matches closely with what it's got in the spreadsheet, and then takes that data and looks at the template it has, so it picks out the correct one, and then what it does, it loads in the standard wall construction, loft insulation, windows, boiler, draft proof and lighting for that property. Then it looks at the data that's in the spreadsheet and it overwrites that data in the template. So the more we have supplied from the client, the better the accuracy of the template that we run. So what we end up with is the spreadsheet. The software chooses the correct closest template and then it overrides and supplements the data that's missing, given as a full data set. So once we have the data in a good format, we go out to take the images. So a typical thermal image looks like the one in the center of the picture, and every image we take is GPS geotagged, so we have a lat and long for every single image which is associated with that image, so we can build maps and we can work out where we've been. It also records date, time, speed, all that kind of thing, which is useful if there's any incidents, you know, around the area. We can tell you exactly where we were and when and, you know, what speed we were going. So we can see a normal thermal image there. So the surveyor takes that image, it's uploaded to head office, where we then remove areas here, so you can see where the dark areas are on the windows and the doors, where the dark grey colours are. We actually remove those areas from the calculation. So if you had a block of flats, we can remove like certain areas of the flat. You may only want the second story flat in the calculation, or there may be a car in front of the building or trees. We can remove all that before we do the calculations. So once we've done that, we have the information there. We apply the Envision algorithm, which calculates regions it believes are regions of heat loss from the property. Then we apply the Envision palette. So any regions that the software believes is in reasonably good condition and reasonably well insulated, it will colour a kind of grey-blue colour, and regions of heat loss it will show as red and yellow and green colours. So red being the hottest regions of heat loss. Where you see white colours, the software doesn't think that's associated with normal heat loss. So it's got a cut-off temperature where it thinks, look, these temperatures are above what I'm expecting to see. So from that we then apply energy calculations. So we effectively run two energy models. We run one without any defects and we run one with the full defects that we've picked up from the energy, the thermal image, and we compare the two. So each thermal image and its data set we process and we run SAP 2012, and then the software generates all the calculations itself and it puts that into an Excel spreadsheet. So typically what you end up with is a spreadsheet maybe with about 30 columns of data. It obviously depends which level of package you go for, but what we end up with, we'll have the property reference number, which will be its unique UPRN, the thermal image as a thumbnail, which you can enlarge to, it's probably about a quarter of the screen. Then we show the energy, CO2 and cost associated with the defect that we picked up. So these are obviously estimated energy losses from those areas. Then we estimate the current SAP rating, with those defects on the property and the potential SAP rating of what we believe that property could achieve if it was brought up to the current building regulations. We also showed the environmental impact rating and its potential environmental impact rating. So these values are very, very important for things like EIS and upcoming English regulations for residential stock, where you have to meet a minimum energy performance standard. So we can also show you the different recommendations. So in this instance we're only shown 2. So if you decrease the U value of the walls to the building regulations, these are the estimated savings, and the roof loft insulation, if you increase the loft insulation in this property to 300 mil, these are the typical savings you would achieve from it. And so we do the walls, the loft, the windows, the boiler heating system, the draft proofing and low energy lighting. Those are the 6 main things we look at. In addition to that, we also include things like the property detachment, the property type, its construction, the boiler that's in there, the fuel types. We also do lookups where we'll see if the property lies within the lowest 25% of the index of multiple deprivation, which would mean it would be under Cisco, under the current ECO classifications, and we give the LSOA code, which is the lower super output area code, and the middle super output area code, and also its regional classification. So these things are all important when you're applying for grant funding of where the property is located. So each spreadsheet we provide, they're quite large sizes, so we deliberately reduce the size of the file. So we may break it up into 1,000 properties per spreadsheet, and we'll also supply an additional spreadsheet which just has the data, so no images embedded, just to keep file sizes down. It allows you to import it into any database systems you have as well, nice and easy. So once we've got that data, we can map it onto Google Maps. We can show you the locations of the properties, we can embed the thermal images, we can show you the Cisco areas on those maps. We can also provide overlay data, so the regions of heat loss appear as almost like a coloured fog, and what you can do with this data is almost take snapshots. So you can have it in 2015, this is where our regions of highest heat loss were. We can rerun the data 2017 once you've done refurbishment measures. You can then take a snapshot of the map, and you can basically see where regions were red and had areas of highest heat loss. You can then see them reduce in colour until they become better and better. So the higher densities of highest regions of heat loss in these images are the red areas, with the green and yellow areas showing less and less. So typically what you can do once you've got your data, you can quickly sort that data by street. So in this instance we're just showing the top 10 streets within our data set which have the highest average heat loss per property. So you can see that Sandhaven Street has the highest energy loss out of all the properties on average. So this is average per property. You can see the CO2 on an average. By insulating those properties and fixing the defects, you'll save approximately £270 on average per property. You can see that on average on those streets the SAP rating for those properties is 38. Potentially you could get them up to 69, and on average we have a SAP difference of 32. So that's the difference between its current SAP and its potential SAP across all of the properties. So we can drill into this data a bit further, and here we can see, if we look at Sandhaven Street, we can see properties 3 and 4, and we can see that 4 Sandhaven Street actually has a saving of £275, whereas 3 Sandhaven Street has a saving of £265. And we can see which properties we really want to target to fix and maximise our CO2 or energy or funding, or which ones can we get up to a kind of minimum energy performance standard, and which ones will never meet the the minimum requirement without having a lot of money spent on them. So we can quickly go through those, and you can break it down into as much detail as you want. This one we have just broken down into the best potential SAP improvement. So again, we've just sorted this by SAP deltas, so we can quickly see which properties we have which have the best potential to achieve SAP ratings. So we can obviously include things like which properties would give the best savings on wall insulation or loft insulation, windows, low energy lighting. What this allows you to do is if there's any kind of eco or grant funding which is specific to one refurbishment measure, so let's just say an eco funder decides that solid wall insulation is what they are looking to fund in the next quarter, you can quickly bring up your top 100 properties which have solid wall are solid wall, and give you the top 50 of those which would give you the highest saving from your CO2. Or you could look to see if you were trying to meet minimum energy performance standards, you could quickly see which ones were going to give you the best, which ones are actually going to be the best potential to reach those standards, which ones were meeting them now, which ones weren't, and you can make an informed decision. So typical things you can do, you can grab graphs from these and pie chart and things showing you the top 10 cities with the highest CO2, and then here we have just some sample images of what you would expect to see and what those defects are. So these two images show typical regions of heat loss from around windows. So this could be caused by poor detailing around these windows, allowing heat loss to escape. It could be that poor detailing has allowed moisture to penetrate into the cavity and actually damage and have moisture within the cavity, damaging the insulation. Or it could be that when they've put these windows in, for whatever reason, the installers have removed or damaged the insulation when they've done it. Here you've got typical slumped insulation. So we can see at the top of these windows, you can see this pattern at the top where you can see the slump. So this is where the insulation has either over time coagulated and fallen to the, via gravity down to the bottom, or again it could be that moisture's gotten in at the top of the cavity and has soaked that down. It's not all bad news. So you can actually pick all your properties that are well insulated. So here we can see these properties are nice and consistent on the walls. The software hasn't picked out any regions of kind of big interest. You'll always get, depending on the construction, there will always be bits of additional heat loss at the eaves details, and there will always be bits of thermal bridging, again depending on the construction. So typical poorly insulated properties, so they will appear kind of red, yellow. Typically these are ones where there's no insulation present at all, and you can see that the savings from these types of properties are much higher because everything coming out of that property is heat loss. And again, we can see on this one, we can see areas where there's quite large areas of increased temperature on these walls. So these ones are typically poorly insulated. Okay, thank you very much. I hope that helps you, and if you have any questions you can contact your local representative. Thank you.